part 2, I expect you to know super well, and there will be questions on code. Okay, I won't expect you to write the whole code for the whole part that you did, but I could pick up snippets of code that you require, that you did do, that was similar in everything, and ask you to do it. Okay, I could simplify your problem saying that the die space can be of only 2 types, instead of the 2 colors and the 4 symbols, and then ask you those questions. So it would be scaled down so that it is not at that level of implementation that you have been doing, but on the same line. So your understanding of your part 1 and part 2 is, that is where your implementation questions on the project would come from. Part 3 and 4 will be comparatively more theoretical. I don't expect you to have coded part 3 and 4 yet, so there will be no implementation questions on part 3 and 4, but there will be conceptual questions on part 3 and 4. So what I do expect you to do is to read through and know it very well, have tried out the timing wheel, the partitions, the kind of questions we were asking you, so that is what you do. One thing that I think is become more like a generation gap than anything when somebody asks me how to review, and I think back, to me the most logical or the most natural way to say to review was that was the time I would use my notes. That was not the time I would read the book or stuff like that. But I know that the learning methodology has changed a lot over the years. I don't find students taking notes. I rarely find students taking notes these days. So of course my idea of preparing for the exam would probably be very different from your idea, your way of reviewing for the exam. So, I don't know what else to tell you. I can tell you what material to expect, but how do you study for it? I don't know. You will have to help me. How do you typically study for it? Okay. As far as the UML is concerned, I think one of you were asking me before. To draw UML diagrams, I only expect you to know 4, which is the class diagram, the object diagram, the use case, and the state chart. And again, I typically lean towards structural more than behavioral, given the fact that you haven't done it as much. The class diagrams are comparatively easier. If I ask you, I will probably not ask you a state chart unless I am very much simplifying it. But know these 4. Okay. The other is the theoretical part that you need to know. Sequence diagram I typically isolate only because that is the only behavioral diagram that is time sensitive. That tells you the order of things that happen in that system. That can only come as pretty much as an objective type of question. Okay, so know that thing about the sequence diagram. But other than that, what is the UML good at modeling? It has both structural, behavioral, the fact what modeling is about, the 4 things initially: visualization, documentation, what was it, design, and I forget the 4th one, but those 4 things there. UML is pretty much simple. You shouldn't be spending more than, at tops 1 hour, half an hour to 1 hour. Sit down on a fresh mind, look through, know. I also suggested, one of you asked me, the way to prepare for UML, I would suggest try to draw these diagrams for your project. That will come in, you will prepare for your final documentation. Don't spend time making it fair and doing it on Microsoft Word or anything like that. Just use your paper and pencil and draw it. It could be your rough draft for your final report, and you have prepared every which way. You have thought about the project, you made a UML diagram, you can use it towards your report in the end, make it fair then, make it neater then. Right now you are not submitting it, but you have gone through the process of thinking and making your draft drawing, so to say, there. But UML you should not be spending at all more than half to 1 hour, whatever it takes you, depending on that. Inheritance and polymorphism, spend as much time as you can. super important. There will be concepts that are coming from the book, there are concepts that, but everything that will come is something that we've talked in class. Nothing will come outside of the class lecture or anything like that. So if you look at something and you say, I don't remember this being talked about in class, you can skim through whatever makes you happier. Okay? But that's any other specific questions other than that? Does that help, Chia?
Can you give a
Yes.
list of the topics that we are going to explain in your final?
List of topics for which one? For the test 2, inheritance, polymorphism, UML and project. That's your list. Right? Everything in inheritance, everything in polymorphism, all parts of project, part 1 and 2, everything, part 3 and 4 more conceptual, no implementation, and UML I just give you the details.
So we don't need to worry about templates?
That's for the makeup exam. Right? So for makeup I sent you the whole list by email. And those of you, very few of you, but those of you who did send me the questions, okay, know that at least one of the questions that you sent me will be on the makeup exam. So those of you who did make the effort of sending me questions, please know the answers to those questions. Okay, they are your questions. Okay? So make sure that you, so I wanted to point that out. So, thank you for sending them, and, so you will get credit for sending them, and, make sure that there will be one question out of the questions you sent. Okay? Good? Anything else?
Can we have midterm question paper?
For studying, you can come to my office and look through it. I won't give it to you to take home. And you cannot take pictures either. But you can come and look through and study if you want to, absolutely.
RTTA is also included, right?
RTTI is part of polymorphism.
So the prior plus and RTTA will not be that completely.
I said RTTI will definitely be a question on that. Every year it is. This year again there is no exception. Again it will be. RTTI is optional if you implement it in the project or not. So how do I know that you have studied that? My other tool is only the exam. So that is why RTTI, definitely a question on RTTI on the exam. Okay? Yeah. And please let me know if you have any other questions related to the exam after class, by email, tomorrow, Wednesday. Don't hesitate, don't think twice, don't think I have sent enough emails. Better ask than not ask. You had a great break. This is the last leg of the semester. We have 3 lectures, 2.5 lectures, if I might say. We have used some time from today. Wednesday we are taking the test, so 2 more lectures next week. Pretty much we'll be doing creational followed by structural followed by behavioral. Behavioral we have only 1, so if needed I will push on some of the structural design patterns for next Wednesday, but roughly speaking, we'll be covering one type of design patterns in 1 lecture. Okay? Before that, I will not be posting anything new between now and your test, but after the test, remember before I start off with this, on project 3, project part 3, I had mentioned that if your game engine has not been to the desired level that you wanted it to be in part 2, then you can forget about part 1 and part 2 for part 3 and 4. The way you do it is by designing a dummy game table class, which does not actually use the game engine, but pretends to use it and just gives some basic, just randomly gives answers, who won, what color won, etc., whatever your arcade needs. Okay, so after Wednesday's test, I will be posting my version of the dummy game table. So if those of you who want to use it, you are free to use my version, you are free to modify it, you can do whatever you desire with that. Okay, so if you are not comfortable interfacing your part 1 and 2 with the rest of it, then you are free to use it. But instead of posting it now and having another thing to look at, I'm going to do any new postings on the website will be after the test. So but that is something, because after Wednesday I'll see you Monday, so I wanted to mention that. And I will be posting your final assignment, which is assignment 4, which will be about design patterns. Okay, which is before the weekends. And that happy Thanksgiving wishes. Belated happy Thanksgiving wishes. And that will be the last assignment, nothing new coming out after that. Okay? So that we have 2 weeks, but I prefer to give it out this week so that next week you are not looking at anything new. I highly recommend, as much as without making a necessity, whatever is the strongest recommendation, to use design pattern in your project. But as I said, it's a soft requirement. I don't, because we can only come to design pattern at this point. But then that's the main reason for the assignment 4. That it is not a topic that was probably taught. It was something that was taught and you work with it. Okay? So if you feel comfortable in using it in the scope of the project, very, very good. If at all you are a little iffy, then at least you have your assignment 4 to work on. Okay, so on that note, I start with the first set of design patterns which come under the creational design patterns. We had looked at some general information about design patterns, that there are 23 of them, that they can be divided into these 3 categories. That is one way of categorizing them. When are they used? So if their purpose is more at the creation time, when does creation of an object happen? What is called when a creation, when we are creating constructors, etc., right? So that's the creation time. Then there is this category of structural design patterns. So if it is related to the structure, okay, so more to the attributes, to the structure of the project at hand. And the third category is the behavior. So if it is more to do with the behavior of this system, what does this system do? Then we are talking about behavior design patterns. What does this system look like? We are talking about structural design patterns. Is there something that we have to ensure when things are created, initialized, creational design patterns? Okay, between these 3 categories, we are looking at 7 design patterns. The majority of them are in the structural design patterns. We are looking at a couple that are creational, and then we will look at one that is the behavior. So you will have a sampling of all 3 kinds of design patterns, and you will know 7 out of the 23. There are 23 design patterns that are out there. So let's start with our creational design patterns. Okay, those are the 2 we are looking at. This is the most simple, and this is the one I recommend using in the project. It is very simple to implement. So if you want to do it, as I said, I almost softly require that you use this one. So these are the 2 we are looking at, factory method and singleton. Again, same book is the source, so if any of you is in the field and wants to, that's a great book. These are the people who put together the design patterns. They are referred to as the Gang of Four. We also said that the design patterns can be divided 3 different ways. The one that I described as creational, structural and behavior, and the other is the scope. And by scope, design pattern can have a class scope or an object scope. So we are looking, the factory method we will be looking at has a class scope, and the singleton that we would be looking at as an object scope. Okay, the way all these 3 PowerPoint slides are designed are, we give you a general introduction and then we talk in detail about these design patterns, including code, structure, everything that comes with design pattern. So the general purpose of your creational design patterns, again as we mentioned, when we are initializing the system, when we are configuring the classes and objects, that is when we think about, we say, okay, I need these things to be done at the creation time. Did others have these things? This pretty much seems that everybody should have required these conditions. So then we look for a design pattern, because then that will serve as a guide to develop our software accordingly. Okay, so remember again, without using the term, so I kind of don't like to use the term template, because in C++ template means has a technical meaning. So if I use template here, I don't mean that template. I just mean the general term template, which means like a blueprint. Okay, so like the templates, here also we are talking about abstract things. This is not real software. This is not code that will be compiled. This is code that is giving you a guide to create your code that will be compiled. Okay, so that's why it is called saying abstracting the instantiation process. So again, creational design patterns with class scope will use inheritance to vary the class that is initiated, and an example of that is the factory method. If we have an object scope, then we delegate instantiation to another object, and an example of that is singleton. So does every design pattern use inheritance? Not necessarily, okay? But it is heavily used, and that is the reason we have to learn our inheritance and polymorphism before we start treading this road, okay? So that is why. You will see in factory method, so inheritance has become a tool, okay? So it's like, I mean, if I take you back to elementary or middle school, right? I don't know if you were allowed to use calculators, we were not. But if you were allowed to use calculators, you had to learn how to use the calculator. After that, now nobody teaches you to use the calculator. You just take it out and use it. It is a tool now, right? So same thing now for us, inheritance is a tool. We've learned about it, we've used it, we know that tool. Okay, so now we are using inheritance when we are talking about creational design patterns in class scope, and when we talk about object scope, we are basically delegating, taking this functionality out and delegating it to another class. Okay, so these are the methods that we are using. The characteristics. Okay, what is a creational design pattern? How do I know what are its characteristics? So you see 2 things that are happening in all the creational design patterns, and these 2 things are, one, they encapsulate knowledge about which concrete classes the system uses. Okay, so remember, what you will see here is an abstract class, not technically, doesn't mean there is a pure virtual method, but it means it gives you the blueprint. Okay, and then you will create that concrete class. You will take this template and you will say, okay, this is what I want. You might want something else in it also. Okay, so that's what it is saying, encapsulating knowledge, because that's the knowledge we are seeking. How do I do this, right? Has somebody else done it? Is there a methodology to it? So that's what we are seeking. And then the second thing is they're saying is they hide how instances of these classes are created and put together. So that is left up till the person who is implementing these design patterns. So they give a lot of flexibility in what gets created, because two of us may be using the same design pattern, but totally different things may be created. Okay, like a factory method, right? There are so many different kind of factories out there. Do they all create the same thing? No. If I go to while we are talking about industries, right? One of the revolutionary concepts is the assembly line technique, right? Earlier it was not assembly line, or not, at least not called. Then it became assembly line, it became automated assembly line, right? Now, how many factories use them? Whether you are creating iPhones or you are creating automobiles, it's the same assembly line technique. So that assembly line technique is the design pattern. Okay? And two totally different softwares will be created. But what is the commonality? That they both use the assembly line technique. So you are not looking for something, a software that does exactly what you do, but is built, had the similar kind of requirements. The final product may be totally different. Okay? I mean, how do you compare an iPhone to a BMW, for example? Right? There's no comparison. But the way it was manufactured used the same kind of methodology. The parts were different. The product was different. But the technique was the same. Same kind, same idea here. So what gets created? Who creates it? Right? Some assembly line people might be working. Another assembly line may be totally automated, robots working. How it gets created and when it gets created. Okay? So all this can be different in different applications. So let's look at a factory method. So first of all, let's have the idea about what is a factory method. So why are we studying design patterns? Because tomorrow when you do software, right, how they were put together was that people have been generating these software, and then some people who have been doing this for a long time or have been evaluating these softwares, they may be at in different roles, have figured out that there are a lot of commonalities. I mean, it's after many years of surveys and collections that we have come to the point. I mean, so this in a way shows the maturity of the computing field. Computing field is very young, but in these 40 years of object-oriented programming, right? Now experts have come, by now I mean in the last 5 years or 10 years, they've come up with this idea that, you know, we can have these design patterns. And now as students, why are we learning it is because tomorrow we are going to develop software, and maybe one of this comes in handy, or more than one of this comes in handy. Okay? So we are studying it from a different, so we have a different starting point as to how they were put together in the first place. Okay, the way they were put together was there was a lot of raw data, and then they were we put them in categories. But the way we are learning is there are categories, and that is how it is generated. Okay. So therefore, first thing we need to know is what is a factory pattern. It says the main idea in the factory method pattern is to isolate the client from the details of the object creation. Why would I do that?
And so that the client is not bothered with the implementation.
Exactly. You bought a house, you want the windows changed. How much about window creation do you want to know? Right. So that's the idea, that the client we are, again, it's about decoupling. Okay? Remember, one of the first questions every class has is, I can do the first assignment in one file. Why is it okay? Because there is that learning curve to put it in different classes, separated, right? So right there, we say no, you have to, right? Now probably you will see the sense of it. The idea is to decouple. Because when we decouple, it is easy to change stuff. Okay? So one of the pervasive themes is decoupling of these things. So here is one. You are isolating the client from, because we are talking about creational design patterns, what are we isolating? The details of the creation, right? So details of object creation. So what is factory? So factory is a class, whatever you will call it in your software. But factory is a class that is used to encapsulate object creation code. In the classes we have written so far, where is the creation code? In the? Okay, forget about the file. Which part of the class? Which method's job is creation? Constructors, right? So we are kind of, so that is in that mini class where, but now we are talking about a bigger entity. If we are talking about the creation of this entity, okay, if I become philosophical, if I say the constructor of the system, that's the class we are talking about. So we are taking the job of creation to a class. Okay, so that's what we are doing here. So a factory is a class that is used to encapsulate object creation code. A factory class initiates and returns a particular type of object based on data passed to the factory. So here is a factory that specializes in creating automobiles. Client can specify, I want a 4-door vehicle that is blue in color, that has this, a V6 or whatever, etc. The request has been passed, the job of the factory is to create it. That is its specialty, to create and return this object. Okay, so that's what we mean by factory class. The different types of objects that are returned from a factory typically are subclasses of a common parent class, the product hierarchy. So now what you are saying is, oh, automobiles, there will be different kind of requests. Can these requests be categorized? 4-door cars, 2-door cars, V6 cars, V8 cars, V4 cars, whatever, So now you are thinking of the hierarchy. So there is this product hierarchy. So the factory creates a set of related objects. So it has the choice in the hierarchy as to what it is creating, and the job of the factory is dependent on the request of the client to create the appropriate object. Believe it or not, although you are not using the design pattern, where if you were using it in your project, where does it make sense to use it? The polymorphism will again become our tool. But where in the project do you think could we use a factory?
The base class can be a factory because you can just use it to as an abstract class and just have function data.
So the dice phase hierarchy can be your hierarchy of products, and where you are creating the dice, so you can have a dice factory which chooses different dice phases. You are doing that. You are not using a design pattern, and your code is not organized as a design pattern, but in a primitive way you are doing that. Depending on the random number generated, you are deciding which dice phase to create. Exactly, that is the idea of the factory. But now you can do it in a more sophisticated manner or a more standardized manner, okay, rather than an ad hoc manner. Many times factory lets a class defer instantiation to subclasses. Here factory is an interface for creating an object and the subclasses decide which class to instantiate, that is which product to use. So let's look at an example, or it's coming in the next slide. So before that, when should you use the factory class? Okay, so this gives you when you should be thinking about the factory design pattern. So you use this design pattern when a class can't anticipate the class of objects it must create. It doesn't know, always that is not the case. It will come at runtime, it will come through an input file. It does not know. A class wants its subclasses to specify the object it creates. Multiple versions of a class need to be maintained. Any of these three things, okay, you can use a factory method. Some of the known uses where it has been used a lot are basically your toolkits and frameworks. All the code that is written for the toolkits, the GUI kind of applications use the factory design pattern. Okay, so that's some software where they have been used. Now here is your structure and class diagram. Here you'll see a little bit of UML in place. Okay, so now remember, this is the structure of the design pattern. This is just a blueprint. Now you decide, it gives you a guide what to create. So what it is saying is, if you have this kind of a problem, then this is what you should be doing. You should have the a creator, a concrete creator, and the product hierarchy. Okay. In our case, if I choose to use this, this is the part where I have my dice space hierarchy. Okay. So what it is saying is, create the product as a hierarchy, and then have another class, okay, whose job is to create these objects. Okay, and if you have been following the way we have been kind of going through the project, your dice class is your creator. Okay, so what you will call those classes will depend on your application. But it gives you a generic structure to follow and develop your software. That is what it is doing. Okay, so product here is a factory method. And the factory method returns a new. So you may or may not have a hierarchy on the creator side, okay, but you always would have a hierarchy on the product side, basically. That's the reason you would have a factory, that you are giving an option of products. If the factory only has one product, then there is no option. Then you don't need a hierarchy. Then you don't need the design pattern. But if there is a choice, okay, when and whether you use here or not will depend if there are the creators can be different. Okay, it's a big industry, different departments. Then you create a hierarchy where there it is abstract. So the factory method could be abstract. Here you will implement it. Or you could have one class only instead of a hierarchy. Okay, but this is using the product there. So let's look at an example. So we have a maze factory here, so it can create mazes. So there are three product hierarchies that are used in this example. Okay, so we are choosing a couple of different things. You have a choice of rooms that you can choose. So there is a room, is a parent class, so room can be an enchanted room or a room with a bomb. Okay, so you're creating this maze. So which room will you pick up? You have a choice of rooms. You have a choice of doors. Do you want a plain door or a door that needs a spell to open up? And then a wall. Do you have a wall or do you have a bombed wall? So the last two is only one class at each level. The first is a room with two subclasses. Okay, so small hierarchies, but the point is I can choose different kind of products to create a maze. What am I going to starting to create is a maze. Okay, and I'm going to choose between these different components. When I'm creating a maze, I want to create a room, then what kind of room? How do I get into a room? What kind of door? Okay, and what kind of walls will this room have? That's how I'm creating the maze. Okay, so again, all combinations are possible. So think of it again. You have kind of done it, but at a different kind of level. In our case, the dice face could be two colors, and then each color could have one of the four symbols or whatever hierarchies we created. But we were only looking at a dice face. Here we are looking at different things. Or in other words, you could recreate that hierarchy using this kind of a thing where you say a dice face, a color, some of you started that way, a color and a symbol. And putting it, which color to pick up, which symbol to pick up, to put on a dice face and create a dice. So if you feel up to it, this is also possible to implement in the project. Okay, but again, now this should be once you have all the basics working. Don't try to do it before everything else is working. So that is what is happening. So room, door, wall are all products. The enchanted room, room with a bomb, door needing spell, and bombed wall are concrete products. Okay? So what it is saying is basically you will not create only a room, or you should create a door. So I think door and wall should also be concrete products. Okay? But they are still products also. Here is the code for it. So maze game has your header file. Again, the things you want to look at is the part which says the factory methods. Okay, so this is your factory that will use the product hierarchy. So what are your factory methods? Make maze, make room, make wall, make door. Okay. You will see that they all have been declared virtual. Because if I need to specialize the creator, then I need polymorphism to work. So that is why the factory methods are all virtual. What other thing do you notice about the factory methods? What are they doing? Look at the names. What are they doing? Don't look at the code. Just look at the names of the factory methods. Make maze, make room, make wall, make door. What is their job? Creating the object. That is what it looks like, right? If I say make door, what do you expect the function to do? Make a door. Right? And how are they doing it? So if I look at make maze, all it is doing is returning a new maze. Okay, this is returning a new room. The n specifies, I think, the number of walls or something here. Okay, make wall returns a new wall. Make door returns a new door. Okay, the door needs the connecting rooms. What is it connecting? So here it is connecting room 1 to room 2. So make a door between room 1 and room 2. All they are doing is making. Only one job, create the product. Okay? Here is your CPP for the maze game thing. So this is the only method that we did not look at. There is the create maze. So this is going to be a maze of rooms. So it is saying, so it starts with a maze pointer, a maze, make maze, creates the rooms, the door from room 1 to room 2. Then in the maze adds the room 1, adds the room 2. Okay, and then sets the sides as to what kind of walls it wants. So it is saying on the north, make a wall. On the east, put a door. On the south, make another wall, and so on and so forth. Okay? What did the maze game? What is the maze game doing? It is the creator method, creator class. Its job is to create. How does it create? It uses these products. Again, if I look at the parallel in our project, creating a dice. How do I create a dice? By using different kind of dice cases. Okay? What it would look like, and you will not be wrong in saying that, it feels like I'm writing even more code for a simple thing. Okay? It is correct. But why am I doing it? Why am I decoupling? So that I can make changes. It is more modifiable without affecting others. That's the idea. Okay? So we are creating more classes, we are creating more code, but that is why we are doing it. Now here is your enchanted maze game. So if you notice, if you follow the documentation, maze game is your creator or factory, and then enchanted, did I pass it? Enchanted maze game is the concrete creator. So you may have one creator, or you may want to specialize the creator. So what if now you say, oh, my maze game was very popular, now I'm coming out with a new version, enchanted maze game, right? So now all you are doing is you are inheriting from that. A lot of things were already done, right? So you are inheriting from that. Now you see the reason why those virtual methods were important? Because now, depending on the object, you can call those methods. So now make room is there, enchanted, now it doesn't return a room, it returns an enchanted room. The make door does not return a door, but returns a door needing a spell. So using different products in the hierarchy now. So the product hierarchy can grow its own way, and the creator hierarchy can grow its own way without being interconnected. That is what has been decoupled. Okay? So someone might have just started with the maze and only those basic door, room, and wall. And then came the second version saying, oh, I now need the enchanted maze, and you extended the hierarchy of the maze, that is the creator class, and you extended the hierarchy of the product classes as needed. In this case, you've added one more class. You may add two more classes. You may add four more classes. But the point is, so here you see the reason why extensibility of a hierarchy is so desirable. All we are doing is adding classes. We are not changing anything in the classes that were previously there. Okay? So that is what is happening. Otherwise, it's same idea. You have now an enchanted maze game, and you have a method cast spell there. And then you have another variety, a bombed maze game. Now when you make a wall, you make a bombed wall. When you make a room, you make a room with a bomb. Okay? So how through that hierarchy you can create different kind of mazes. You can specialize it even more, right? So that's what you are looking. So now that we've seen an example, you have a better idea of a factory method. You've seen an example. Now we are trying to remember, we had talked about what are the elements. One important part of a solution is, so you say, so tomorrow if you end up making, if you in your projects or in your softwares, whatever you are doing tomorrow, if you are saying I'm going to create something where I might use one type of this, another type of this, again from a real life experience. So, in some years from now, you might be buying your first house, or you might building you might say, I'm going to get my house built because I want so many different features. It should be custom made. So now you are choosing you are shopping from a wide variety of doors, wide varieties of windows, wide variety of sidings, wide variety of rooftop material. I mean, you are living this every day. Okay? Here you are converting it into software. But whenever you are in that situation, your mind should say, does factory method make sense? Okay? The fact that factory method is there does not mean you have to use it. It is there to make your software development easier. That's the point of all these creation of all the design patterns. That they are tools for you. There are guides already there. So once you say, okay, does factory method make sense? And you read it up and you say, yes, it makes sense. Then you look at this and you say, what kind of things do I have to create? And that is what it is saying. You have a product and a concrete product, which just means that you have a product and you can have different types of those products. You know, when you say windows, what are my choices? So window may not be a choice. The different types of windows are the choice. So that is why the window becomes the product and the different kinds of windows become the concrete product. Because you will choose one of those types of windows. You won't just say a window. Okay, then you have so that is the product and the concrete, concrete product. And then you have the creator and the concrete creator. In many cases, they may be just one. You may not have the hierarchy there. You may just have one. But those are the elements of a factory. Okay, the beauty of it, that they can both extend their own way. I don't think you will have a chance to do it, or I don't want to add another assignment to it, related to it, but what you might want to do is, later on, look at your own dice classes, okay, and your dice hierarchy, and reflect on the fact that if you needed a specialized kind of dice, would you need to change code? Okay. And chances are that you would need to change code, because you did not think of this thing before. Nobody asked you to think. But if you use the factory method, even if you didn't think it is in the right manner, that it can be extended. That is the advantage of using design patterns. That these have proven to be useful for extensibility. Okay? So that is the story about your factory method, basically. The next one is the singleton, and as I mentioned, this is probably the simplest design pattern, and therefore I highly, whatever word appeals to you, recommend you to use it in the project, and softly require you to use it in the project. Singleton, the job of a singleton is, if in a software there is an object that you want only one of, okay, two of those objects should never be created. That's when we use that. In our project, what can you think of that only one of that should be created?
Game.
Many games we create on many tables. The timing machine, the timing game. As many game tables, as many players, as many games going on those game players, between everything, I only have one time machine. One timing game. Okay. In our project, why can we do it without singleton? Because we just create one object. And we say, I'm not creating, I don't need any more. I'm just going to create one timing wheel object, that's it. Right? But if it is a big software, like think of the term, early on we talked about constant, right? The const keyword. Why do we put the const keyword? Who is it supposed to help? Are we putting a restriction on someone by using const? It feels like that, but if you really think of it, const is a facility for you as a programmer. You want to make sure this thing doesn't change. It's a check for you. Because when does const give error? At compile time. Have you ever seen an error for const at runtime? No. And who sees the compile time errors? The programmer, the developer. The client doesn't see compile time errors. So if you think of it from that point of view, const is a facility for us as programmers. That's one way to, when we say something const, we say, oh, you know what, I should not change it. Let me make it const. Because then if I change it, I'll see an error. Same is the idea here. If this is a big project, and I want to make sure that I only create one timing wheel, then I use singleton. That's what the term means. Singleton means only one of its kind. I will not create two objects of that class. I only want one object of that class to be created. Okay? That's the purpose. How we do it, we are going to look at it. So the purpose of the singleton pattern is to ensure that the class has only one instance and provide a global point of access to it. Okay, so when should I use it? So this is how we are learning it. What is it? When do we use it? How do we use it? That is the code part, right? And then move on to the when should we use it? The application part. So when should singleton be used? Use the singleton pattern when there must be exactly one instance of a class and it must be accessible to clients from a well-known access point. When the sole instance should be extensible by subclassing and client should be able to use an extended instance without modifying their code. That is another reason. So it may be extended, it may be specialized, but it will be only one object of that kind. Okay? Where have these used? They have been used a lot to maintain meta classes of classes. What are meta classes? When you want to store information about classes and objects that are created, those are known as meta classes. Meta anything means information about that kind of thing. Like you might have used read the term metadata. So you have data. So data about that data. How many, right? Or what's the average? What's the median? That is information about this data. All that is metadata. So meta classes are classes that want information about classes that have been created. So that's somewhere where these have been used a lot. But anyway, so here it is as I said super simple. You create a class that's known as, you can call it singleton, you can call it whatever you need to call it, and all it has as a data member is a static unique instance and a singleton data, and then you instantiate those data. Okay, and that's the job of the instance method. The thing that you will notice is now that it has static members. Remember, static members are members of the class and not of the object. Okay, so this design pattern uses static members. So in a way, as you are reading design patterns, also consciously absorb the fact that you are going to see everything we learned in this semester. Whether it was early part of the semester or later part of the semester. So we talked about static much before. We've been talking about inheritance and polymorphism more lately. But it is like a culmination, after how you do your projects at the end of your degree. This is like kind of using all the material we have covered till now and then bringing it all together here. So implementation-wise, these are the details we need to know, that the singleton pattern is implemented by declaring the constructor private. So you will see, so because the constructor is not public, the object cannot be created. So it will create that one object which is a static. Okay, so that it's a class. It's from the class thing, and nobody can create a object after that. So that's why the constructor is made private. You provide a pointer to an instance of itself. So that's the way you access it. You provide an operation that returns its existing instance. So what it does is it's very clever. You don't create an object, right? When do you create an object? When you need it, right? So you cannot create it. Instead, what happens is it returns the created instance, the already created instance. So the client is happy, but a new object did not get created. Okay, so we'll see how that happens. And if it is the first time it has been requested, it will create it. But after that, it will not create it. Okay? Or constructs the instance if it does not exist and then returns it. Both the pointer to the instance and the operation that returns the instance have to be implemented as static members. That's a requirement because static belongs to the class. So there will only be one instance. Object, when it is not static, it belongs to the object. So every time you create the object, the instance is created. Okay? And let's look at a guideline or an example here. So the singleton class looks like this. It's very small, very simple. So things to note here are the pointer to the object, this kind of an object, right? I would say pointer to itself because it is static. It is not a class member. I mean, it's not a object scope. It is class scope. It belongs to the class. Is a pointer to itself. Okay, called instance here. This is just a variable. You don't have to worry. But it's a pointer to a singleton which belongs to the class. In the public method, right? What do you have? You have a pointer a method that returns a singleton pointer. Okay? And what did you do with the constructor? You threw it in the protected. Okay? So the constructor is not public, and you have a static method that returns the static pointer, which is a pointer to itself. So that is what your singleton class looks like. Now let's look at the implementation. Because it's a static member, that is how it has to be initialized. So it is initialized to be null. So initially it does not point to anything. Okay? The constructor is not public, so the client cannot use the constructor. So how does the client request this object? Through the instance method. So through the class method called instance. So it calls saying singleton instance. Now what does it do? It checks. If it is null, then it constructs it. It can use the constructor. It's in the protected section, right? It's just not in the public section. So it creates it. And if it is not null, then it does not create it. In both the situations, it returns the underscore instance, which is a pointer to the object. So if you look at the class, it's not a big humongous amount of code. It is a very compact, simple code. But it helps you, So do you have to call your class singleton? No. You can call your class timing wheel. What would you do if you were using this method, this design pattern in your timing wheel? You will call it timing wheel, but now you will take the constructor to the protected section. Your pointer to the timing wheel will be a static. You will create that as a static method. Okay, so there will be changes that you will do. And then you will have the static instance of method. And in the client where you declared the timing wheel object, instead you will call the timing wheel instance of method. You will create a timing wheel pointer and call the instance of method. Okay, so in your code, those are the changes you will make. But you were already creating only one object. So it's just using a design pattern in your project. But this way, if two modules in your project were creating a timing wheel, right? Then actually only one would have been created. Okay. You could use it for your dice if the requirement was the same dice should be used by all the tables. So the arcade creates here is a variation, right? The arcade creates the dice for the day. And all the tables use it. So instead of creating so many objects of that kind, you only create that one object, and that is what is wrote. Okay? But that is a way to ensure that there is only one object of the class. Okay, so here is an example. Remember the maze factory we were looking at? So if I only wanted one maze factory, I could create a lot of mazes. I could have whatever rooms and walls and bombs or bomb rooms or doors or whatever in that. But I want to ensure that there is only one maze factory in my project. Okay, you can't create two objects or two maze factory objects. Then that maze factory has been created on the singleton pattern. The name you call whatever you want, so I don't use the term singleton, I use the term maze factory, but look at that. The constructor has gone in the protected section, in the public is a maze factory pointer, that is a static member, and in the private section is your, sorry, the other way. In the private section is your maze factory pointer, which is a static member, and in your public section is the instance method that returns that maze factory pointer, which is another. Remember that static members need static methods. So static members cannot be returned by regular methods. A class can have both static or non-static. By non-static we mean regular methods that we put in. Okay, but a static member needs this, and a static member needs to be initialized. And that's what is happening here. So the static one is initialized to a null pointer that is typecasted to a maze factory pointer, and the instance method does the same thing. If it is null, it creates a new one, otherwise it does not, and it simply returns the pointer. Okay? So those are that's the method you provide. In these examples, the constructor is empty, just to keep it simple. But your constructor does not need to be empty. It will have the constructor code there, whatever you need to be done there. Okay? Here, just to not to worry about the code there, it is left as an empty method. But the constructor code is there. What has been done is it has been moved to the protected section. So client cannot declare an object to this class. How does the client ask for an object? So instead of creating an object, you ask for an object using the instance method. You create a pointer and call the instance of it. The class itself creates the object and ensures that it only creates one object only. Okay? So that is, when do I use it? Do I start using it for every class now? No. I use it for a class where I have to make sure that there should be only one object of this class. If you find that requirement anywhere, then you use these design patterns. Okay? So again, to kind of put it all together, what are the elements of the solution? You said, okay, I have this situation, looked at when should it be used, you saw that yes, you qualify. You have, so then what kind of things you have to do? You create an interface operation that lets client access its unique instance. That's the instance of method that we had been seeing. The operation may be responsible for creating its own unique instance. Okay, that is what we saw. It was creating its own if it was null. Clients access a singleton instance solely through the instance operation. If there are a lot of singleton classes in the project, we would write a class template of singleton and other singleton classes can publicly inherit from it. If you were writing a project where a lot of elements, right? Let's say a university, there should be one registrar, one bursar, one president. So you see that there are a lot of entities in the university that are singleton. One library, right? So what do? Now you see a lot of singleton. So you create a base class and they can all be child classes. In C++, that is what you would do. You could use multiple inheritance because if you needed to, this is a singleton also, but it was also a specialized something else, right? A bursar and an assistant bursar. So that kind of a thing. Or if you were working in Java, this could become an interface also. Because there you can only extend one class or inherit from one and you implement interfaces. So what technique you use will depend on the language you are using. Design pattern is language independent. I have picked up code examples that are C++ because we are using it in a C++ class. but I could use this presentation in a Java class by changing the code into Java. Okay. The way it is implemented will be different, but the ideas are the same. Design patterns are language independent. It doesn't matter which language you are coding. Okay, they are just guidelines. So here this one shows you some code here. So this is your template of a singleton class. Okay, and that you might be, or you could be creating a template. You may not even use hierarchy. You may instantiate a template. Okay, so this one is using a template. It says the class name, the type of the parameter will come later at time of instantiation, but there will be a static pointer, right? T pointer that we've been seeing, the method, the constructor in the protected section, and here are the methods. Okay, it has your some other stuff also. There is your D instance that releases the instance's memory, instance without the parameter, etc. So it depends on the template basically there. But you can, the idea here is that you can create a template and then use that. Okay, and that gives you the implementation of those methods. The other way to do is to inherit. So you can use, you can create a singleton class, and then you can use, here you are creating a concrete singleton class, okay, and inheriting from a C singleton class, which was a template, and you are instantiating it with itself and character. Okay, so it's a combination of using inheritance and templates. So again, more in form of information for you. I would not be asking you questions. No, on this test, design patterns are not there on Wednesday. Okay, but the 20 points that you will take in the final exam week, still I would not ask you questions on this part. Okay? And here is the test code for that application. It looks complicated, it is not that complicated, but the template example will not be, I would not ask you questions on the template part. Okay? But if you sit down and look at the code later on, it is simply on the same pattern as the generic, the one we saw with the pointer and the constructor and this thing. Another way to look at it is there is so much you can do with what you have learned. It is between now the inherit, and everything goes together. They are not in isolation. Everything goes together in software development. Okay? Till Wednesday, forget this. Don't worry about it. Forget we talked about design patterns, anything. Focus, study, whatever makes you do well. Everybody can, benefit from doing well. So use your next 2 days, and I'm hoping you use your break also and time before that to do the best you can on Wednesday. Now Wednesday decides a big chunk of your grade. Okay, there are still things, the assignment grade has a big chunk remaining in the project, and there is the 20 points to the final exam and design pattern. So there is still room after this exam, but this is the big chunk. Okay, now you will be done with more than 70% after Wednesday. So if you have only time to study a couple of things, inheritance, chapter 4, chapter 5. Whatever you can, the best you can. If you have to study, or if you have only time for that, study it as well as you can. That is your heart and soul of the course. Okay? You can bank on whatever you've been doing with the project. Don't leave any question unanswered. I typically tell the students, if you find something that you are having a very hard time with, okay, put it on me. Say you asked a question that you were not supposed to ask. Okay, it's out of course. It was not, I was not supposed to study it. So think totally that it was not in course. Now let your brain process it. You will respect your brain a lot more than you do. Your brain is capable of a lot of smart things. Instead of, I'll give you an example. You give a question that is a little tough. What will students do? You would find, you taught them quick sort, you ask them a different application of quick sort. So, and this I'm saying out of just pure experience. Students will write the whole code of the quick sort you did in class. Because quick sort is the method, quick sort is what seemed to be, the common term. You will score far less than if you read it independently and now let your brain process it as an independent problem. Forget about that you learned quick sort, then answer it. Chances are those answers are much better. So it's the same thing when I start grading and I see, okay, here I see, over the years I kind of know the kind of answers I will get, right? So you see that, okay, here it starts what you knew about something related to it. Say, okay, you kind of know what you are expecting to see, you grade it accordingly. But then come a couple of answers that I call are smarter answers. You did not know the answer, you probably did not do that part of the project, but you thought about the problem. You thought about the question and you answered. Your brains are much smarter than you think. So give them that credit. Let them, do that accordingly. Any question on the question in the test, please ask me. Okay, I remember last time when we were discussing, a couple of us had come up saying the questions were difficult. So if there is a problem in communication in my language and in your language, please bring that up. Don't hesitate, ask me at the end. It is your grade and I want to give you the best grade that you can possibly earn. Okay, but you have to earn it. Enough of pep talk, study and do well on Wednesday. Okay?